Section 1.5, Applications and Modeling with Quadratic Equations. The first type of problem that we're going to do in this section uses the Pythagorean Theorem. So here's a quick reminder. Anytime we have a right triangle, we have a side called a hypotenuse, which is across from the right triangle. Across from the right angle. And then we have two legs, A and B. So in our equation, a squared plus b squared equals c squared, A and B are always your legs, and C is always the hypotenuse. Example 1. A piece of property has the shape of a right triangle. The longer leg is 20 meters longer than twice the length of the shorter leg. The hypotenuse is 10 meters longer than the length of the longer leg. Find the lengths of the sides of the triangular lot. So every single one of these problems, you'll need to be drawing a picture for. So we've got a right triangle. Let's see, it says that the longer leg is 20 meters longer than twice the length of the shorter leg. So we're going to say that the shorter leg is just x. The longer leg is 20 meters longer than, so we're going to have 20 plus twice the length of the shorter, so 2 times x. Anytime we have something that says 20 more than or 20 longer, that's going to be 20 plus. Anytime we use the word twice or 3 times or 4 times the length, then that's going to be a multiplication. And then we've got the hypotenuse, which is 10 meters longer than the length of the longer leg. So we're going to take our long leg and we're going to add on 10 more, 10 longer. So this can actually simplify to 2x plus 30. Okay, Pythagorean theorem tells me to take leg squared plus leg squared equals hypotenuse squared. All right, so now we're going to need to do box method or FOIL with our two binomials that are squared. So I'm just going to FOIL this. We're going to have 20 times 20, which is 400. By the way, this is 20 plus 2x times 20 plus 2x. So 20 times 20, and then we've got 20 times 2x, which is 40x. And then we've got 2x times 20, and then 2x times 2x. Okay, and then I still have this plus x squared going on right here. And then again, we need to FOIL. So this is going to be 2x plus 30 times 2x plus 30. So 2x times 2x, we get 4x squared. 2x times 30, and 30 times 2x, and then 30 times 30. Okay, so now we have a quadratic to solve because I have x squareds going on. So I need to, oh, I just noticed a mistake that I made. That should have been an x squared. I forgot my squared. Okay, so now I need to get everything on one side. And what I want to do is first look at my x squared terms. So let's see, I've got an x squared here, an x squared here, and an x squared there. So I want to keep my x squared positive. If I move all of my x squareds to the right side, I'll end up with a negative x squared term. So I'm going to move everything to the left. Let's start by moving our 4x squared over. Well, this 4x squared and this 4x squared just cancel out. I can go ahead and add these two together. I can add these two as well. Okay, and then I'm going to rearrange the left side so that x squared comes first. And I'm also going to subtract over this 120x and subtract over the 900. So we're going to end up with x squared, and then 80x minus 120x would be negative 40x. And then if I subtract the 900 from the 400, I'm going to get negative 500. Okay, and now it's time to factor. So if we set up our x, we're going to have negative 500 in for our A times C, and then our B is going to be negative 40. So now we need to figure out two numbers that multiply to 500 and add up to 40. We'll deal with our negatives, or add up to negative 40. We'll deal with the negatives in a minute though. So if you're not sure, you can write out all of your factors of 500. This might take you a minute, but you'll definitely find them eventually if you just write out all of your factors. Hey, you going for a walk? Oh, peekaboo, sorry. Peekaboo. Peekaboo. Okay, have fun. So after writing out some factors of 500, I came across 10 times 50, which if I have a negative 50 and a positive 10, those can add up to negative 40. Always double check your factors, make sure that they multiply to what you want and add to what you want. Okay, so jumping back into our problem, since we have an A value of 1, we can use our factoring trick where we just do x minus 50 and x plus 10. Set each of those equal to 0 and solve. We get x equals positive 50 and x equals negative 10. Okay, on all of these word problems, you need to make sure that you go back and you read the problem again and figure out what it's asking for. So the question here says, find the lengths of the sides of the triangular lot. So my answer isn't just x equals 50 and x equals negative 10. I need to answer the question in the end. So first of all, let's go back and see what x stands for. X was a side length of a triangle. We've got two options for x. It's either going to be 50 meters or negative 10 meters. And honestly, only one of those makes sense. So sometimes you may have to cross off one of your solutions for x because it doesn't make sense. So the lengths of my triangle are 50 meters for the short one. If I plug 50 back in here, I'm going to get 120 meters. And if I plug 50 in here, I'm going to get 130 meters. So there's my answer. Applying area of a square. First of all, let's recall that area of a triangle is length times width. Our problem says one square has side lengths 5 inches longer than a smaller square. The sum of the areas of the squares equals 37 inches squared. Find the side length of the bigger square. So we are going to need to draw a picture for this. We have two squares. Got a bigger square and a smaller square. It says one square has side lengths 5 inches longer than the smaller square. So let's say the smaller square has side length x, and the bigger square will be x plus 5. So to find the area of the big square, we're going to multiply length times width. So we have x plus 5 squared. And then the smaller one will be x times x, which is x squared. So the sum of these areas is 37. So we have x plus 5 squared plus your x squared equals 37. Sometimes I see students try to square the 37 because there's a 2 on the unit, but that's not what that means. Inches squared just means that it's been multiplied inches times inches. Okay, so here we go. X plus 5 squared, you're going to need to either do FOIL or box method. I'm going to do FOIL here. I combine some like terms on the left side. X squared plus x squared is going to be 2x squared. 5x plus 5x is 10x. And now I'm going to need to subtract over that 37 so that everything's on the same side. I have a quadratic to solve here because there's an x squared. And I noticed the first thing I could do is I could divide 2 out of both sides to make this problem a little bit easier to factor. So if I divide everything on the left by 2, and I divide 0 by 2, I'm going to end up with x squared plus 5x minus 6 equals 0. Okay, if I set up my x now, a times c is negative 6, and b is 5. The two numbers that multiply to negative 6 and add to positive 5 are 6 and negative 1. Always double check those in your calculator. And since a is 1 on this problem, I can jump straight to x plus 6 and x minus 1. Now if I set those each equal to 0 and solve, I'm going to get x equals negative 6 and positive 1. So if we remember what x stands for here, it's the side length of a square. I know that x cannot be negative 6. You can't have a negative side length. So x is 1. Let's go back and read our problem again because it probably doesn't just want x equals 1. The problem says find the side length of the bigger square. So this one was our bigger square. So my side length is 6. 6 inches.